When a fish swims through the water, it generates an electric field which is detected by the sharks. These sensors wouldn't work anywhere near as well in the open air, but salt water is an excellent conductor of electricity. Even a stingray, hidden beneath the sand, is not safe from the sensors of a hammerhead shark. So, while its name might suggest anything but refinement, the hammerhead shark, as seen here, does have a very refined sense of electroreception. That's thanks to the size and shape of their broad, flat heads, meaning the apillae are spread over a greater surface area, so sensing out prey is made that much easier. And now, to an animal that's an exception to the rule, and just about every other rule. The platypus, known too as the duck-billed platypus, is a semi-aquatic, egg-laying mammal found only in eastern Australia and Tasmania. The first scientists to examine a specimen believed they were victims of some elaborate taxidermy hoax. Well, the platypus is definitely a one-off. It has a duck bill and webbed feet, a beaver tail, and the body shape and fur of an otter. Male platypuses are also venomous, with sharp stingers on the heels of their rear feet that will knock out just about anything with a pulse. These Australian mammals are bottom feeders that will hunt underwater. In spite of their mishmash of physique, they make surprisingly graceful swimmers. They paddle with their front-webbed feet and steer with their hind legs and that beaver-like tail. When they submerge, folds of skin cover their eyes and ears and stop water from entering, and their nostrils are sealed shut. The platypus can remain underwater for a minute or two at a time, using its sensitive duck bill to find food. Shellfish, worms, larvae, and insects make up the bulk of the platypus's diet. Along with bits of mud and gravel, all these consumables are stored in pouches in the platypus's cheeks. When they come to the surface, they mash everything up and eat it, using the bits of gravel to help them chew their food. Well, after all, it's not like they have teeth. But if their eyes and nostrils are closed underwater, then how do they manage to sense potential food when it's around? The answer can be found on its duck-like bill. Each and every platypus bill contains around 40,000 electroreceptors arranged in rows. Electrical impulses alert the platypus to objects underwater. Electrical currents travel through water better than air, and the platypus's side-to-side swimming style surely helps conductivity too. Let's head back to dry land, to the forests and woodlands of either Papua New Guinea or Australia. That's where you'll find this spiky fellow. The echidna, a short-beaked echidna in this case. Sometimes known as spiny anteaters, the echidna is, like the platypus, an egg-laying mammal. If you live in Australia, you have seen its likeness on the 5-cent coin. But unlike the platypus, the spiny anteater spends all of its time on dry land, giving it the distinction of being the world's only terrestrial egg-laying mammal. The echidna is also the only land-born mammal we know to possess the supersense of electroreception. Put simply, hundreds of receptors concentrated in the tip of the snout allow it to pick up on natural electrical stimuli. This is particularly useful when it comes to hunting for buried prey. The short-beaked echidna, as seen here, uses those electroreceptors to pick up on the movements of ants and termites. Concealed as they may be to the naked eye, but the humidity of their nests, particularly after the rain, is a dead giveaway. And now, from curious egg-laying animals to a creature that most of us would probably pass by without a second thought, given the opportunity. We speak now of the dung beetle. Not the most glamorous of creations, this humble insect is actually remarkable in several ways. Okay, let's deal with their diet first. Just as their name suggests, dung beetles are beetles that feed exclusively, or for the main part anyway, on dung and feces. Industriously laboring away on the lower end of the food chain, they possess exceptional talent as dung disposal units. Why a single dung beetle can bury dung that is 250 times its own body weight in the course of one night. Because this critter does a lot more than just live up to its name. It calls to mind something the writer and wit Oscar Wilde once said, "We are all in the gutter, but some of us are looking at the stars." Well, as it turns out, the dung beetle is looking at the stars. Dung beetles have compound eyes that are built for low light. While most insects would only be able to see a few of the brightest stars in the sky, the Milky Way's distinctive streak of light is a useful navigation cue. It has been deduced already that dung beetles use polarized moonlight to walk backwards in a straight line. But figuring out how they orient themselves on moonless nights has just been discovered. scientists tested the idea that dung beetles exploit the starry sky for orientation. They created special little hats made from black cardboard, which were taped to the heads of dung beetles. The hats blocked the beetles' view of the night sky and confirmed the scientists' hunch that these insects navigate by using the Milky Way's map of the stars. The theory was confirmed in a planetarium, where a projection of the Milky Way was turned on and off. The dung beetle is now in the sensory spotlight. The humble poo gatherer presents the first documented use of the Milky Way for orientation in the animal kingdom. A sunset is a thing of beauty, but it's more than that for songbirds. Recent research in two songbird species, Swainson's thrushes and gray-cheeked thrushes, has demonstrated that. Scientists are positive these birds could detect Earth's magnetic field even if they're not quite sure how. While it's well documented that animals such as sea turtles rely on internal stores of mineral magnetite, which act like tiny magnetic needles in the animal's cells, how birds do it is still a mystery. Receptors in their eyes, or do they do it with their sense of smell? The jury, so to speak, is still out. Whatever the case, even though these birds are well equipped to detect Earth's magnetic field, they also need to calibrate their internal compass from time to time, on a daily basis in fact. Relying solely on Earth's magnetic field could have the effect of blowing the songbirds off course as the field shifts direction in their North American breeding ground. Enter the sun, which always sets in the west. It's nice to know that even for animals with superhuman senses, sometimes the eternal verities stay true. On Animal Super Senses, the stars are the senses. And in this episode, they've taken us from the ocean's depths to the skies above, from life teeming beneath our feet to one of the largest creatures on Earth. We have been on a journey of senses, superhuman animal senses. But the trip is far from over. These incredible powers of perception will live to fight again another day. So join us next time on Animal Super Senses.